I think you'll agree that knowing your times table makes the rest of mathematics, and particularly the arithmetic parts, a lot easier. Similarly, with number sequences, there are several sequences that it is really quite important that you know off by heart and can recognise very, very quickly. The sequences of odd and even numbers are the very basic ones, and in a different video we've looked at complicated ones like the Fibonacci sequence. But the ones that are really key to your GCSE studies are square numbers, that's very basic, triangle numbers, a little bit more complicated, cube numbers, well that shouldn't be too complicated for you, and then prime numbers. Prime numbers is an interesting one for which there is no mathematical formula, but we're going to have a look at them anyway because they're in of their own right an interesting sequence of numbers. So let's start with square numbers. Square numbers are very simply an integer times an integer. So what we get there is something we sometimes call a perfect square. Examples of this are 9, which are 3 times 3, 16, which is 4 times 4, and so on. Visually, we can look at this and see that if we can get a pattern of square dots out of a number, then that number is a perfect square. And it can therefore be described by the equation that the nth term is equal to n squared. Square numbers crop up everywhere. You need to know that sequence, that 1, 4, 9, 16, 25. You will see it time and time again. Okay, the second one, triangle numbers. First triangle number is 1, and the second triangle number is 1 plus 2, which is 3. The next triangle number is 1 plus 2 plus 3. The fourth one is 1 plus 2 plus 3 plus 4, and so on. So we're adding up all of the numbers that we've got to. Visually, it's quite interesting to see how this goes. If you play snooker or pool, you'll recognise this shape. It's the way that spherical balls fit together in a pyramid. The nth term for this is n times n plus 1 divided by 2. And there is a really interesting proof of this that you can look at in the links alongside this video. There is a trick in working out that formula that gives an interesting insight into the way that great mathematicians' minds actually work. The next one, cube numbers. Well, if you understood square numbers, cube numbers should be no difficulty to you. It's just integer times integer times integer. So 1 times 1 times 1, or 2 times 2 times 2, so on. And again, visually, if we put a pile of cubes together, a set of bricks, we can do it as a 1 by 1, a 2 by 2, and a 3 by 3, or a 4 by 4. And we'll see that we start to get quite high values building up. 4 cubed is 4 times 4 times 4, which is 64. So our nth term for cubic numbers is n cubed. So we're going to talk about prime numbers for a little while here. Prime number is an integer that has exactly 2 factors, the number 1 and the prime number itself. So 3 is a prime number because no other integers divide into 3 except for 1 and 3. 5 is a prime number. Same thing, no other integers except 5 and 1. 2 is the only even prime number. Obviously this is true because all other even numbers divide by 2. 1 is not a prime number. It only has one factor, the number 1. All in all, if you count them up, there are 168 prime numbers that are less than 1,000. And if we look at the first 10 primes, we can see that apart from 2, as we've said, they're all odd numbers. But they go up in a, well, if you want to try and work out that sequence, you can. It will be an interesting sequence if you ever get to work out what it is. But don't let me stop you working it out. There is a thing called the Riemann hypothesis, which theorizes about the spread of prime numbers through the number system. People have tried for the past 150 years to prove the Riemann hypothesis. Someone has to do it one day and get the £1 million prize for doing so. Work hard at your maths and it might be you. So our knowledge of some of these basic sequences should help us with some of the simple questions we might get asked about sequences in exams or tests. A couple of examples. So here's a sequence: 1, 3, 6, 11, 15. You should recognize this as triangle numbers, except for the number 11, because the number that goes in there is the number 10. So clearly you would be able to say which number that doesn't belong in that sequence. Here's another question. You're given a sequence of numbers and asked, does the number 101 belong in this sequence? Well, you should very quickly be able to notice what that sequence is. It's the sequence of square numbers. 1, 4, 9, 16, 25 is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. Does the number 101 belong in that sequence? Well, the question you're really being asked is 101 a square number? Well, no, it's not. We know that 100 is 10 times 10, and we know that 11 is going to be much bigger than 101. So 101 is not square, so it's not in the sequence. So knowing your basic sequences, your squares and your cubes and your triangle numbers, gives you the knowledge to be able to very quickly answer some of these questions without going into the deeper underlying mathematics of them. You didn't need to work out the formula for each of those equations to understand that in the first instance one of the numbers wasn't supposed to be in there, and in the second instance a particular number wasn't part of the sequence. Understanding the basic sequences will give you the confidence to do this with more complicated examples.